Okay, let's start with a small introduction. We're already running out of time now.
We are.
Because it's going to be difficult. My name is Ryan Ververs-Bijkerk. I'm a technologist working independently. I help my customers actually experiencing good user experience, at least that's my goal. But I'm also doing a lot with infrastructure as code. I'm very active in the community, and you can look me up. I'm together with Eltjo.
Thank you so much for the introduction. So hey guys, my name is Eltjo from Gulik. I am a principal product manager at Citrix, and in that regard I'm responsible for everything to do with HX, graphics and seamless. Now today, as I said in the introduction already, while we solve the problems, we are going to take you on a journey. And the journey is to unravel the puzzle that is user experience, especially within VDI environments. So I see a light going off instead of going on. There we go.
So it's not going to be the 10 pieces puzzle?
No, it's not going to be your puzzle. No, it's not going to be your puzzle this time.
But before we go, let's do a quick introduction of GoUC. So if we think about GoUC, there is one famous quote here is, doing research is creating new knowledge. And this is actually the reason why we started GoUC, because we love exploring new technology. So therefore we basically created a non-profit foundation for creating or researching the new knowledge. So if you look at the mission statement of GoUC, it's actually researching new technology to inspire and serve community, so communities like this, to provide new knowledge. And we do that on basically multiple ways, so it's doing infrastructure as code, but also researches of performance researches based on user experience, but also scalability terms. Now we do have one sponsor which is basically with us from the beginning, and that's LoadGen. And LoadGen is a load simulation tool which can simulate user behavior on VDIs, but also SBC, but also in web-based applications. So if you have the time, we really can recommend to look up LoadGen. So everything that we do, we published on our beautiful website. I'm still so happy with the website. So
remind us, who created the website again? There you go.
Yeah, that was me. No, so this is so everything that we do is published on the website. It's open and free. You can just read it. It's in a blog format, and
no registration required.
No, and everything is just there. So enough about GoUC. So let's continue to the real presentation.
The real presentation.
The real presentation.
The stuff why we're here, right? And again, it's not about puzzling, right? That was just a joke. But it is about user experience. And if people think of user experience, you can have a lot of different definitions. So what I did is I looked up the official definition of user experience. And if you look that up in the dictionary, it says the overall experience of a user using an application or a website, especially in terms of how pleasing it is to use. But that doesn't really help us much, does it? Because really. User experience can mean a lot. And user experience is also highly subjective. And I tried to think of an analogy to show you guys what user experience is. And I came up with this one. And these are actually two cars. I'm not going to tell you which one's mine and which one's Ryan. But I can tell you he's self-employed and I'm not. So take that how it is. But there are two cars, right? And cars do the same thing. They have a pedal that makes it go. They have a pedal that makes it stop. And a round thing that makes it go around the corner, right? So you would think that the user experience would be broadly the same. However,
are your pedals still in your car working properly? Or?
Okay. I admit, mine is a 21-year-old Mazda MX-5 and it doesn't always work, okay? Right, so in terms of user experience in that regard, not the best user experience. On the other hand, I would argue that my car is easier to operate because it only has a couple of buttons and that's it. Your one is way too fancy, right?
It is fancy and it works.
On the other hand, thanks for that. On the other hand, if you were to be an American, for example, and would never have driven anything like the stick shift, yours is much easier because mine has an extra pedal and a stick. So user experience is very subjective, right? Now, it's not only subjective. We all know that user experience can go from to in a matter of minutes or a matter of seconds. And it's highly dependent. So let's say we ask Esther here how her experience was when she logs into her VDI. And it takes about 15 seconds to log on, right? And we asked that on a Monday. And it's raining. And she had a shitty weekend. And her car broke down. Because probably also a Mazda MX-5, right? And you ask her, hey, how was your user experience? She's probably going to say, nah, it sucked. if you ask her the same question, for example, on Friday, right? Same question, same log on time, 15 seconds, but the sun is shining. She had a lovely lunch. She's looking forward to the weekend. She's going to have a weekend away with her spouse. And you ask her, how was your user experience? She's probably going to say, oh,
fantastic.
Yeah. Wasn't that bad, right? So it's also very time dependent. So that doesn't really help us much, right? To determine what user experience is, because it's very subjective. We need a way to quantify that. To quantify that, he said.
Quantification.
Quantification. And with quantification mean we need to put a number to it. That way we can compare it.
But if I say my user experience is a 5.
Yeah, that's a bit difficult, right? How do we interpret that?
But is it scaling from 0 to 5, or is it 0 to
100
or 100?
So, jeez, there we go. It's difficult, right? And what we normally do in these kind of things is you have a research, right? You get a group of people into the room, 4 groups, a focus group, and you show them user experience, and you have them rate it. And you have to make sure that there are the group has all the different backgrounds, all the different kinds of people, and you get a mean opinion score in there, and then you get a user experience.
But is it reliable?
No. And it also takes a lot of time. We don't have that time. So we came up with something else to make it easier, to break it down, to make it more abstract. And in that regard, we boiled down user experience in VDI environments. Oh, yeah. So we boiled it down to 3 different.
Off the tape. Okay.
Lots happening here, guys. Lots happening here, guys.
Continue.
I'm like a hamster. So we boiled it down into 3 distinct categories: latency, audio quality, and image quality. And in our context, these 3 key metrics will be the basis of how we perceive user experience. So, without further ado, because we only have not that much time anymore, because we talked about Ryan's puzzling. We'll jump right into the first one.
We had a very complex puzzle, Eltjo, to solve.
For sure.
Actually getting the presentation going.
Yeah.
But let's first start with the first topic, which is actually latency. So if you look at the definition of latency, it's basically the following statement. Now I can read it, the entire section. It's not really beneficial, but the essence is here is the time delay transmitted, so it's from one point to the other point. So if you look at the context of the world and also with Azure, it's the latency towards the various locations. So if we're located here at the ITQ office, which is near Amsterdam, Ververs-Bijkerk to be specific, the nearest location is going to be West Europe, which is a data center.
Yeah, exactly.
Because it's a location that is near the physical location where we're at. So if you go to other locations, so another one for example, in the UK, the distance is going to be longer. So it's also going to take longer to transmit the data towards that.
Yeah, that's the laws of physics, right? And we can't change it. We can do a lot, but we can't change the laws of physics.
So this extends, and it gets even worse if you go to over the pond, so towards the US, or if you're in the US towards us. There is even more left, and how further you go, the more latency you will get. So we're lucky here, at least in the Netherlands, because we got actually the data center here near Amsterdam. It's not Amsterdam, but it's a little bit more upwards. We're not just Amsterdam. So our connection is relatively high. So we always have a low latency towards the data centers. So therefore, from a latency perspective, it's always the best experience. So there are tools out there that you can use to basically understand the latency. So I think this is a website. If you Google for Azure Data Latency, you can actually select the various locations, and based on the location you can see what the actual latency is from your physical location towards the data centers. And this is important because you have to understand the time it takes towards connect towards a data center. Because the reason why this is important is latency is workload dependent. So if you look at the use cases that we have in our context, so if you're browsing the web, a higher latency is acceptable because you're interacting with a web browser or web page, the data is loaded, and then you will just scroll through. So in higher latency doesn't really matter. But if you continue towards a gaming context, a higher latency can actually make or break your game. So it's really important to have a low latency as possible. But it's also for the unified communication. So if you use Team, for example. And it even gets more critical if you're looking at the banking sector, where they have the traders on the floors. Actually, the requirement is 0.001 millisecond latency. It should be...
Yeah, between the click and the buying of the stocks can be thousands of dollars is less latency.
Indeed. So it's really important to understand the context of the workload that you're serving, and it's dependent on what you have.
I completely agree.
So if you talk about input latency, there's a lot of steps involved, especially also in VDI. So you have interaction with the physical mouse or a device. So usually when we have VDIs, it's a mouse, but it can also be like a gaming controller. But that signal has to be processed. And at first going to be processed at your endpoint. It's going to go to the CPU, it's going to be in a render queue, and then it's going to be actually on the display itself. But if you add a virtual desktop to it, it also has to go over the internet and then towards the remote desktop, and there has to process again. So that means when introducing latency or when introducing a VDI, it actually adds latency to it. Now to demonstrate this, we have a small demo.
Yeah, so hopefully it works. Let's see if we get this working, but I'm a bit of an amateur programmer. And I love programming, and oh, there we go, lovely, lovely. And I need a volunteer, Esther. Esther, can you come join the stage, please? I want to play a game with you.
I will hold the mic for you, so you can actually focus on the gaming.
Yeah, come over.
So we have
the screen. I hope it's visible for everyone. We're going to play a game. I don't know which side you are.
Me neither. Oh, wow.
Which one are you, Esther?
I have no idea.
You're going to be this side.
Yeah.
That's what I figured. It's not very responsive.
Oh, Esther, you're so bad at this game.
Oh, okay. Now I know what you already did. Mr. Latency,
you see the clue? Exactly, exactly. I've been very cheeky here. Because one of these controllers has 0 latency, and the other one, the one I gave Esther, has a dynamic latency somewhere between 20 and 50
if you switch...
Oh. No, this wasn't part of the... I'm supposed to be very good at this game. Come on, my game.
Which side am I on now?
Yeah, you're
that
the other
one,
side.
right?
Yeah, the one is winning, right? Oh, there we go. So Esther, how important is input latency?
It's super important, Eltjo.
Super important, there you go.
It's the difference between winning
and losing.
And having to cry through the night just from this humiliation from your BFF.
And what do you think of my game?
That always cheats out of game night and now puts me on the stand here. I love it. And I'll go back because I'm stealing time.
But actually this is a game from your age?
This is, thank you very much. Yeah, I played this when I was younger, by the way. Yeah. Thanks so much. Without input latency, by the way.
No, but actually the demo showed that the latency is important. And if you have like a delayed input latency, it can make or break your game. So, therefore it's always important to have a lower latency.
Now, there are a couple of ways to measure input latency, right? Let me see if I can get this working. And one of the ways to measure input latency is a very simple one. You can all do that at home. Is by using a modern phone, right? We all have a modern phone, and all modern phones are capable of recording. And these newer phones, as you can see on the screen, can record in very high frame rates. This is 480 frames per second. And with that, you can see that the motion that's normally fluid isn't fluid at all when you boil it down, when you get it down to 480 FPS.
Well, this is not really a nice way to measure, because you have to...
It's not. It's very simple, but you have to count the frames, and then you can deduce the time it takes between the frames.
So luckily there are other tools out there, and one of those is the NVIDIA LDAP.
Yep.
It's the latency display and analysis tool.
Yeah, exactly. Very good.
But this is actually a tool that's produced by NVIDIA, which will measure the latency, and we can actually demo for it. and it should play. So this is my setup at home, which is actually a Counter-Strike game. And what it will do, it will simulate the mouse input, and that will respond in a fire, so from the AK, and that will measure the actually change. So they will create the muzzle flash, and we can basically detect that with the LDAT tool.
And then you know the time it takes between the mouse click actually pressed and something being detected on the screen.
Indeed. So this is a really reliable way from actually measuring the true input latency from a device. And you can also do this on a virtual machine, of course.
Yeah, there's just one downside to that, right? The big downside is NVIDIA doesn't sell the LDAT. It uses it internally. We use it at Citrix. They supplied it to some journalists and researchers, but you can't actually buy the device. Now, what I did a while ago is I created an alternative for that using a very cheap microcontroller, in this case an Adafruit Qt Py, and a light-sensitive sensor. And that basically does the same. You can hook it up to your machine. It'll simulate either a mouse click or a keyboard press and can detect changes in luminance or color. And you could use anything for that. You don't have to use Counter-Strike. I'm not very good in Counter-Strike, to be honest.
Yeah.
I'm a little bit older than Ryan. What you can do, for example, you can use this, hook it up to your machine. And yes, I know my screen is very dirty. I know, I cleaned it afterwards. But what you can do is you can, for example, have PowerPoint on and let it change slides on a mouse click or a key press from blue to green.
Yep.
And you can detect how long it takes. Now, once you do that, you get some interesting data, right, Ryan?
Yeah, so we have multiple researches on the GoUC website. Yep. Actually, I published one yesterday, which is using this methodology at least to detect the different configurations. So I really can recommend to go read those. So I'm quickly going to ask our timekeeper here how much time we have left. 5 minutes.
5 minutes. Oh, we really need to step up our game.
Okay, so we're going to do this really quickly. Unfortunately, we lost a little bit of time at the beginning, but let's continue to the audio. Audio is quite complex, but in general, it's basically sound waves, which is received by your ears, and that is producing sound. You have animations for that. It's displayed in hertz. You got the low vibration or the slow vibrations for a lower pitch, the rapid vibration for a higher pitch. And this is basically how sound works. And this is one cycle. So sound is also dependent on age.
What?
So
seriously?
It is confronting, I know, Eltjo.
Oh dear, yeah.
But in general, and I think everybody understands this, the older you get, the less hearing you have, and you can especially basically test this with like an hertz meter.
Sorry?
So,
oh yeah,
indeed. Yeah. Check. So I'm gonna skip this one. Gonna skip this one. Yeah. So in general, it is important when you look at sound, and also in a VDI context, that the sound is in sync.
Oh yeah.
Oh. Because once sound is off sync, it's really annoying, at least to, for example, have a conversation. So if you're doing a team session and the sound is not in sync with your lips, you can really quickly notice that.
And why did you have a picture of this device then?
That's a good question. So this is, so if you look at the Hollywood, but also productions, and actually have it here. But it's making sure that the audio and the video is in sync. So by making a clap or a clap sound, you have a spike and you can basically sync it up. And that's the reason why they use that also in video productions. So to really quantify it, and unfortunately I cannot show all the demos because we don't have the time, but there are methodologies out there that you can basically quantify the quality of sound. It's called VSQL, so it's the Visual Speak Quality Object Listener. It's not something that we have come up with.
No. I don't think a native speaker came up with this abbreviation as well.
But this is a methodology, but produced by Google, where they actually using. I'm not sure if they use AI.
Yep, they use machine learning
models to basically quantify the audio quality.
Yep.
So again, we have used this for also research. It's I think it's in one of the team's researches where we actually implemented this in a research. So again, I recommend to read the research up. And then you have like, I think 1 minute to to this
1 minute. Let's go, let's go. Okay, image or video quality is also very important, right? If you are in a Teams call, for example, and the audio is very crisp, but you can't see your other people, or they look like 8-bit Mario characters, it's not going to be a good user experience, right? So I quickly wanted to talk about what image quality is and what moving images are. And moving images are actually nothing more than a rapid succession of still images. There we go. This was first shown in 1878, where a guy, I forgot his name, put 12 pictures of a horse in rapid succession, and he created the illusion of movement. And now, this was the first time that it was done, so he was labeled as a magician. I think they even tried to burn him at the stake, but that's another story. Now, for our eyes to perceive images as moving images, fluid motion, you need at least 24 frames per second. And let's take 30 frames per second, right? And with 30 frames per second, each frame is only visible for 33.3 milliseconds. That is very quick. And I can put that into context as well, right? An average human blink takes 100 milliseconds, right? And we blink every 4 to 6 seconds. That basically, by the way, means that 10% of the time we're clinically blind, right? Well, fortunately, our brains fill that in. But 100 milliseconds is very quick. 33.3 milliseconds is even quicker. And if you take a raw, uncompressed 4K image, that is around 25 megabytes. And that's not that much in today's standards, right? But if you have to show that for 30 FPS, that is 750 megabytes per second. And if you want an even smoother experience.
That was a really smooth experience,
right? That takes 1.5 gigabytes per second. Now, that's not really handy to throw over a LAN network, right? So we need something to compress that. And for that we use video codecs. And video codecs are everywhere, right? It's used Netflix, YouTube uses video codecs.
Netflix is even like one of the leading standard,
exactly, for sure,
doing a lot of development efforts in video codecs.
Because if they can lower the bandwidth, they can up the quality of their stream. So it's very important for them. But it's also very important for us at Citrix and other remoting protocols, because they help us reduce bandwidth usage. And that's exactly what video codecs do. Now, not all video codecs are the same, right? There are older video codecs, there are newer video codecs. Way back in the days, we started with H.264 or AVC. Then we moved up to H.265, HEVC, and now we got modern protocols, modern video codecs, AV1. And if you look back when H.264 was invented, that was roughly 2003. Ryan here was still in kindergarten when that happened.
Thank you.
Thank you. No worries.
I'm not that old like Pong, but yeah, I'm quite young, yeah.
Okay, just kidding, guys. So one of the newer video codecs that we have is called AV1, and it is, compared to all the other video codecs out there, it is very efficient. So it has very good image quality and it has superior compression. And if you want to know more about video codecs and how we use that in Citrix and HDX, I would highly recommend you check out the Rodi Kossen session. I think it's around 8:30. Check it out, because he's going to deep dive into all the different settings we have in HDX and all the different video codecs types that are out there. Now, I'm going to skip these slides just because we don't have that much time. Quickly wanted to touch upon how video codecs work. And the way they work is that they don't send over each frame in its entirety. What they try to do is they send only the differences between two frames over. And you say, how difficult is that? Well, I looked it up. I used ChatGTP. And in the process, I went into a rabbit hole, 4 days last, and then I knew everything about discrete cosine transformations, entropy decoders, interframe prediction, movement factors, quantization, rate control.
So if I understand correctly,
it's difficult.
You can actually now do this yourself, or?
No, I can't.
Oh, okay,
no.
So
I can pretend to.
Still generated like ChatGTP.
Exactly. Now, the question that we had is basically the same question that we had a while back in audio. Right? It's very easy for us to see that there is a difference, a quality difference between the two images we showed you here. The right one is of a much lesser quality than the right one. We can see that because it's blurry. It's not as sharp. But if I ask Ryan, how much better is that image? It's difficult to quantify, right? Fortunately, we
0 points.
Exactly, yeah. Yeah. You knew it was coming, right? Fortunately, we also have a metric for that, and it's called SSIM. It is a metric used to quantify perceived image quality, right?
So,
and now we can put a number to it.
I actually said 0 point something. But
0 point something, yeah. Now this is a measurement. Oh, what do you want to ask
actually,
me?
I want to explain a little bit. So this also really depends a little bit on what type of data you have, because we already experienced that this is one of the standardized metrics or measurements. But it's difficult and depends on the context.
Exactly.
Unfortunately, we don't have the time to actually explain it, but
but we can quantify it. Let's give it at that. If you want to know more, we have a lot of stuff on our website that you can read.
More posts.
More posts. We also have, last thing, 3 slides, Esther. Actually 2 slides. So key takeaways here.
It's a long sentence.
It's very important to understand your type of workload, because not all workloads have the same user experience. If you compare someone who does light office work to a CAD/CAM worker, or something that Benny showed us, where they have 3D images going through a cathedral, there might be very different requirements in terms of user experience than for a typical office worker. And you can tweak the protocol based on the workload that you have. Again, my colleague Ryan has a very good presentation that's coming up later on.
Why are you promoting Rody?
Rody's my friend, my buddy, my partner in crime.
So there's another also cool session regarding remote display analyzer, which is also regarding
a very good
tweaking.
tool that you can use, for sure. Yeah.
It's actually my session with Bram. No, but again, you can actually reduce latency by selecting the data center near you. So it's important to actually understand where your user is coming from. And actually, I'm experiencing it currently at my customer, where they have accidentally given a workload or a VDI in Brazil, but connecting from India is not working that good.
Now, the biggest key takeaway that we want to give you guys is make sure that you take what we have, don't take it for granted, but test it yourself. Because without data, without testing it yourself, you're just another person with an opinion.
Thank you.
Thank you.